Hello viewers, welcome to Shiksharthi, and today's our topic is Factors Part 2. In our last video, we have discussed the various concepts on factors, how to find number of factors by normal conceptual method we have observed. What are called factors, how many factors will be there for various situations like prime numbers, composite numbers, prime number square, prime number to the power of 4, and how to find the number of factors without actually writing them we have discussed. So today we'll try to generalize all these things, and also we will be looking at the different type of questions possible on factors. So first thing, we'll see the alternate method to find number of factors. In the reference, you can take this number as 24, say 1 into 24, 2 into 12, 3 into 8, 4 into 6, total number of factors are 8. I gave an alternate method if you remember. 24 can be written as 2 to the power of 3 into 3 to the power of 1. I said 2 power 3 can be taken as 2 power 0, 2 power 1, 2 power 2, 2 power 3 as factors, and 3 power 1 can be written as 3 power 0, 3 power 1 as factors. So here we got 4 factors and here we got 2 factors. Ultimately 4 into 2, 8 factors are there for 24. This is what we have learned. And what are these 8 factors? We can see the list of 8 factors over there. And what are they? How to get them? 3 power 0, 2 power 0, nothing but 1 into 1 is 1. Then 3 power 0 into 2 is 2. 3 power 0, that is 1 into 4 is 4. 1 into 8 is 8. Then 3 power 1 into 1 is 3. 3 power 1 into 2 power 1 is 6. 3 power 1 into 2 square is nothing but 12. And finally 3 power 1 into 2 cube is 24. These are the list of factors. Now in this, what are the things we can observe? After writing the number into prime factor form, you know this 2 and 3 are prime numbers. So you can see for 24, we have 2 and 3 are only prime numbers. Rest of them are other numbers, like except 1. Rest of them like 4, 6, 8, 12 and 24 are composite numbers. These all discussions we have made it. Just to remind once, I have taken all these things. Now the shortcut form or the generalized method for this, any number given to us, let us call it as m, and n can be written in the form of a to the power of p into b to the power of q into c to the power of r and so on, in which we consider a, b, c and so on are prime numbers, my friends. These are prime numbers. Like you can compare with this part. So you can say in place of a we have 2, in place of b we have 3, in place of p we have 3, in place of q we have 1. So you can compare them. So ABC represents prime numbers, and those ABC are called as distinct prime factors for the given number 24. So I can say in 24 only 2 and 3 are prime numbers. Okay. Now after that, my friend, what I did, whatever I got in the form of a to the power of p and b to the power of q, I have written them into factors. I split them into factors. Like 2 power 3 is nothing but 8, and the numbers which you see here, 2 power 0, 2 power 1, 2 power 2, 2 power 3 are the factors of 2 power 3. So here power 1, so I got 3 power 0 and 3 power 1. We should always start from power 0. Okay, power 0. Now you can see when the power is 3, I got 4 total number of factors. When the power is 1, I got 2 total number of factors. So if I generalize this, my friend, what I can say, number of factors will be in the form of p plus 1, and for the second part, the number of factors will be q plus 1. Some product of these two will be the total number of factors. So if my question is to find total number of factors, that includes list of prime numbers, list of composite numbers and 1. So all the types of numbers are together written here. So the general form I can say after converting the number into prime factor form will be a p plus 1 into q plus 1 into r plus 1. So you can see, if you understand the concept clearly, this is not to be called as a formula or any shortcut. This is something by observation we can always derive and we can use it every time. Now this method can be applicable for any type of numbers which we have. Like for an instance, if you remember, for 144 we have got 15 factors. So I want to prove that 144 using this concept here. So 144 in a prime factor form 2 times 72. I should divide with the starting prime numbers if possible. Like 2 again, that will be 36, again by 2 it is 18, again by 2 it is 9, by 3 it is 3. So this will be 2 to the power of 1, 2, 3, 4, so it is 2 power 4 and 3 square is what you have. Now what I should, my friend, this is in the form of a to the power of p into b to the power of q, and my answer to find the number of factors is simply p plus 1 into q plus 1, which we have already discussed. So let us get this, all of you. 4 plus 1, this is 4 plus 1, and here q, in place of q we have 2. So 2 plus 1, ultimately it is 5 into 3, that is 15 factors. So you can say 144 has got 15 factors. In my previous video I have listed all those 115 factors of 144. So I guess you all got clear now, without writing the factors, how to find number of factors, which is very common question in the competitive exams or any type of examinations where you are reading factors. This can be one of the questions on factors. Now moving on to next, all of you. So if you want, I can show you one more example on this. You can make a note of this thing. Like for example, if I say 256, I'll divide this by 2, it is 128, by 2 again it is something like, what you get, 64. And we all know, see, if I go on, right, if you have an idea directly, I can say this is nothing but 2 power 8, or else you please do this once. This is 2, 32, it is 2 times again 16, by 2 times again it is 8, by 2 times it is 4, by 2 times it is 2. So I got 256 as 2 to the power of 8. So the total number of factors is 8 plus 1, which is how much? 9. So 256 will have 9 factors in total. Okay, all of you? Now, let us move on to next point here. See, if you see the previous slide, there are types of questions which are possible. I'll tell you one by one, okay? Suppose my question is, how many prime factors are there? That you know how to see. We have already made a highlight on them. 2 and 3 are prime factors we have. Composite numbers. See, what is composite number? The number which is not prime and 1. So other than 1 and prime numbers, rest of all the numbers are called as composite numbers. So if I remove this 1 and 2 and 3, rest of the numbers like 4, 6, 8, 12, 24 are composite numbers. So what I should do, my friend, in order to find out the number of composite numbers, first try to know how many prime factors are there. So in case of 24, we have 2 prime numbers, and additionally we need to remove 1 also, because 1 is neither prime nor composite, so I should remove 1 as well. So total number of composite numbers will be total factors minus prime factors minus 1 is the answer for that. So logically, if you think, it will be much easier. How to find total number of factors? You already got the method here, okay? So that we can utilize it here. Next, there can be some other type of questions here. Find the number of odd factors. I'll take a reference every time, my friend. I'll take another slide here. I'll take another number also here. For example, if I take a number like 72. 72, 1 into 72, 2 into 36, 3 into 24, 4 into 18, 5 is not a factor, 6 into 12, 7, 8, 8 into 9. Is that clear, all of you? Now, if I want to know how many odd factors are there in this, so this is 1, 2, and further if you see 3, and the next one, no. So, number of odd factors I can select out of 72 is how much? 3. Now, I don't want to write, please understand, if the number is big, I'll get a lot of factors. I cannot write each and every factor and then identify all these things like odd numbers, even numbers, like that I cannot do. So, I need to have a logical approach every time. I can find the number of factors, that you know it, fine. So I am not even doing that. I am going by method. You see, 72, if I write into prime factor form. 2 times it is 36, again 2 times it is 18, again 2 times it is 9, then 3 times it is 3, and we can see by the last pair itself it is 2 to the power of into 3 to the power of 2, nothing but 72, in the form of a to the power of p and b to the power of q. Easily I can find the number of factors. 3 plus 1 4, 2 plus 1 3, 4 into 3 total 12. So you can see here we have 12 factors, correct? Plus 1 to the powers and multiply. It's a simple way to get the number of factors. But here I am not trying to get the number of factors. Here I am actually trying to know how many odd factors are there and how many even factors are there. So we all know if the factor is not an odd number, then it has to be an even number, and the number which is not an even number, the factor which is, if it is not an even number, that it have to be an odd number. So that we know, very well know it, right? So I am trying to find number of odd factors. How do we do this? Listen all of you. 2 power 3, we are doing it for 72. Please do not forget, this is the same thing I am taking here. And we got 3 power how much, friend? 2. So this I can write into factors: 2 power 0, 2 power 1, 2 power 2, 2 power 3. And here 3 power 0, 3 power 1, 3 power 2. Now if you include these factors, then you get even numbers. If you multiply with them or if you take them, then definitely the factors have to be even numbers. But if you target only these, not even numbers, if you target only 3 power factors, like 3 power 1 is 0, 3 power 0 is 1, 3 power 1 is 3, and 3 power 2 is 9. You can see 1, 3 and 9 are only odd factors. So how many odd factors are there, my friend, here? 3 odd factors. Now out of 12 factors for 72, if 3 of them are odd, definitely remaining 9 would be an even factors. Am I right or wrong? So this is the way to find out the number of even factors and odd factors. Let us take a little higher level example. Okay, this 72 was very easy. So let us take a little more higher number. Suppose if I have n value, which I say in a prime factor form, it is 2 power 5 into 3 power 4 into 5 power 3 kind of a number after converting into prime factor form. So this is prime factor form of a number given to me. Okay, prime factor form of number is given to me. Now what I should do, my friend? I should find total number of factors. First question, total number of factors if I wish. Then power plus 1, power plus 1, power plus 1. So 5 plus 1, this is 4 plus 1, and this is 3 plus 1 is what I need to do. So this is something like 6 into 5. 6 into 5 is how much? 30. 30 into 4 is 120. So total, this number, whatever the number it is, has got total 120 factors. Imagine writing 120 factors or listing out 120 factors is not at all going to be an easy one, right? And the number is too big. It is 32 into 81 into 125, so it is going to be huge number. So finally 6 into 5, 6 into 5, 30, 30 into 4, 120. So this number has got 120 factors. Now how many odd factors are there? For that, what I should do? Odd factors. Please understand the concept here, please. Concept. So we have 2 power 5, we have 3 power 4 and 5 power 3. Further splitting into factors. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. Right? And this is 3 power 0, 3 power 1, 3 power 2, 3 power 3, 3 power 4. This is 5 power 0, 5 power 1, 5 power 2, 5 power 3. Okay, all of us, we know. Here we got 6 factors. Here we got 5 factors, and here we got 4 factors. The product of these 3 is what I got it here. Now my question is to find the number of odd factors. So what I should do, my friend, to find the number of odd factors? I should not consider 2 power 5. I should only consider 3 power 4 and 5 power 3. So product of, like, you know what I am trying to do, 5 power 0 is 1, 1 into 1 is 1, 1 into 3 is 3, 1 into 9 is 9, 1 into 27 is 27, 1 into 81 is also 81. All these are prime numbers, odd numbers. Similarly, 3 power 0 into 5 power 0, that is 1, 1 into 5, 5, 1 into 25 is 25, 1 into 125 is 125, like that. If I multiply an odd number with odd number, the product is definitely an odd number here. So here we have 5 different values and here we have 4 different values. Product of these two will give you number of odd factors. So number of odd factors is 5 into 4 is how much? 20. So out of 120 factors we have for this number, 20 of them are possibly odd factors. So out of 120, if I subtract 20, the number of even factors would be 120 minus 20, which is 100. So that is how we find the number of odd factors and number of even factors for the given numbers here we have. Now let us see the other type of questions in this. So till now we learned how to find total number of factors, number of prime factors, number of composite factors, and number of odd factors and even factors. These are the questions. Now in this again, let us also quickly understand how many prime factors are there and how many composite factors are there. If I say prime factors, my friend, prime factors, you can see the bases are only 2, 3 and 5. So only 3 of the factors are prime. Out of 120, only 3 of them are prime. Now if I talk about a composite, now people generally say that anything which is other than prime is called composite, but we should also remove 1 out of the list. So here out of 120, I should remove 3 factors of prime and 1. So total 4 factors I should remove. So out of 120, if I remove 4, 116 will be the number of composite factors. So number of composite factors also we got it here. Okay. So in a continuation of this, I will take it like next here. The given n is 2 to the power of 5, 3 to the power of 4 and 5 to the power of 3 was the given number. And now we are trying to know number of factors which are multiples of 5. Which are multiples of 5. Okay. So now if you remember what we said here, 2 power 5 can be written as 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. 3 power 4 can be written as 3 power 0, 3 power 1, 3 power 2, 3 power 3 and 3 power 4. And 5 power 3 can be written as 5 power 0, 5 power 1, 5 power 2 and 5 power 3. Now here please understand, to find the number of factors which are multiples of 5, better you find the factors which are not multiples of 5. Not multiples of 5. If you observe, if I use these two without using the last one, I'll get the number of factors which are not multiples of 5. And I also remember the total number of factors. So from the total number of factors, if I remove all the factors which are not the multiple of 5, then automatically I'll be left with the numbers which are multiples of 5. So here I got 6 different factors and here I got 5 different factors. 6 into 5, 30 factors are there out of 120 which are not multiples of 5. Without involving 5, I got all the numbers over there. Okay, so also we should remember these things like now all this. So here I should remove this 30 in order to get the number of total number of factors which are not a multiple of 5. Now do we also have to consider this 1 separately? I guess not required, because 1 into 1, 1 into 2, 1 into 4 already we have in the list. So those things are already considered here. So these 3 numbers we should not multiply, right? So here 30. So out of 120, I should remove 30, which is nothing but how much? 90. So there are 90 numbers which are multiples of 5 here. So this is the method to find the number of multiples of 5. There is an alternate method here. Straight away we can find out. What I did here is a reverse method. First, I got all the factors which are not multiples of 5. So 2 multiples, 2 factors, 3 factors I have multiplied, I got 30. From the total factors I have subtracted 30, I got that number. That is one method. The other method is same 2 power 5 has got 6. 2 power or 3 power 4 has got 5, this, and 5 power 3, I should say this are the factors, correct? If I multiply with these, please understand, if I multiply with these, not with 5 power 0, what is 5 power 0? 1. Multiplying with 1, any of these cannot be a multiple of 5. I want a multiple of 5. So I should multiply either with 5 power 1, I should multiply either with 5 power 2, I should multiply with 5 power 3, or even I can multiply with all of them, right? So here there are total 3. So multiply 6 into 5 into 3. Multiplying with 5 into 5 square into 5 cube with these possibilities will give you total number of multiples of 5. Like 6 into 5 is how much? 30. 30 into 3 is how much? 90. So there are 90. You can see the same answer we have got it here in this case. Now similarly, I can also find number of factors which are multiple of 15 or any other number. Let us take 45 for example. My number was n is equal to 2 power 5, 3 power 4 and 2 power, that is 5 power 3 as a number. I want to know number of factors which are multiples of 45. Now multiples of 45. So I know what is 45 is. 45 is something like 9 into 5. So it is 3 square into 5. So any number which is multiple of 45 have to be a minimum 3 square into 5 into something. Correct? It could be 1 or any other number it is. So 2 power 5 we all can write as 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. That is total 6 possibilities here we have. 3 power 4 we have 3 power 0, 3 power 1, 3 power 2, 3 power 3 and 3 power 4. Total 5 possibilities are there. 5 power 3 can be written as 5 power 0, 5 power 1, 5 power 2, 5 power 3. That is total 4 possibilities and we all know it is total 120. Now if I am looking at numbers or the factors which are multiples of 45, I should minimum have 3 square and 5. Minimum 3 square and 5. So I'll remove this. Minimum 3 square is required. So I can take 3 square, 3 cube, 3 power 4 and minimum 5 is required. So I can remove this part also. So I can take 5 or 5 square or 5 cube. That's fine for me. And all the values of 2 power. So what I'm left with, my friend, all 6 we can take it here. Here 2 are eliminated out of 5, so 3 can be taken here, and out of 4 we have eliminated 1, so another 3 can be taken here. So total 3 into 3 9, 9 into 6 is 54. There are 54 factors out of 120 in the given number which are multiples of 45. Such questions we can definitely handle, and more interesting questions are going to come in my next following video. So till then, take care and thank you.